Lesson 6.14, writing equations for polygons, slash, word problems and substituting, slash. Okay, so what you're going to want to focus on for this lesson is at the bottom of page 217. There, we have a lot of different polygons and shapes, two-dimensional and three-dimensional. For the two-dimensional shapes, we're calculating area, and for the three-dimensional shapes, we are calculating volume. Ooh, melty cheese. All right, so there it shows you all the equations for shapes and how to get their areas and volumes. And of course, those equations are variables because not all shapes are the same. So you have to have a variable that you can plug in different values for the letters. All done. Okay. So let's see how it works. We're going to turn some word problems using some equations we know and substituting some values. All right, this is going to be a good lesson for word problems. So I've actually written out 7 of them. We're going to go through 7, and hopefully that gives you a good understanding of word problems as we keep doing them. So these word problems are asking us to represent the areas and the volumes written out using the values they give us. So we're going to be referring to those formulas on page 217, or if you don't have the book, obviously, you can just look at the areas for these different shapes online, but I'll also be writing them down for you. So it's asking for find the area. So a rectangle is twice as long as it is wide. So we know we're going to be working with the area of a rectangle. What is the area of a rectangle? Area of a rectangle is the length times the width, okay? Or you can say the height times the width, or the length, or whatever you want to call it, whatever. We'll use height times width. That way we don't confuse that L for 1. So a rectangle is twice as long as it is wide. So let's turn this English sentence into a math sentence. So a rectangle is twice as long as it is wide. No, see? Sometimes you got to be careful. So we want to figure out a different way to rephrase this. So so rephrasing it is the length of the rectangle is twice it. Oh, well, there it is. There's the is we want. We don't want this is, we want this is. So the length of the rectangle is twice as long as the width. There we go. All right. So now that we got that sorted out, let's also say the height of the rectangle is twice as long as the width. So height equals 2 width. Perfect. So now we have our h. All right. And the important thing is we want to write a sentence with just one variable. So let's rewrite a equals hw. So we have an equation for h, so let's go ahead and substitute it right here using parentheses. Area equals 2w times w. So now that we have a variable or an equation with one variable, we just want to simplify it. So area equals 2w squared. So what's nice, and that's it. So so recall that the problem is asking for represent the following areas in terms of one variable and simplify. So the reason this is helpful is because we've rewritten the area as in terms of one variable. So we only need to know one value in order to know what the area is, as opposed to having to plug in both, finding both, measuring both, and simplifying. Because we know that the length is twice as long as the width, it simplifies things for us. So later on, if we know the width, we can just substitute it into this equation and get the area out. So for example, if the width is 3, 3 squared is 9, 9 times 2 is 18. So if we have a width of 3, we know the area of this rectangle is 18. Excuse me. Let's take a look at the next one. A parallelogram's base is 1 foot more than 3 times the height. So let's find what the area of a parallelogram is going to be. First, it is going to be area equals base times height. Okay, area equals base times height. So it says the base is 1 foot more than 3 times the height, or in other words, 3 times the height plus 1. 3 height plus 1. All right, so now that we have singled out one of our variables, we can substitute. So a equals, substitute in the b, 3h plus 1 times h, and then simplify, we just distribute that h, 3h squared plus h. And once again, we've rewritten the area formula. Instead of writing it in terms of 2 variables, we now have it in 1 variable. So we only need to know one thing in order to figure out what the area is. Okay, a circle's radius is represented by x minus 5. So we need to write down what the area of a circle is. Area equals pi r squared. All right, and it says that the radius is x minus 5. So we only have to do, all we have to do in this one is substitute. So a equals pi, substitute the r, x minus 5. Recall, it's only replacing the r. The radius is this. So that means we're just replacing the r. We're not replacing the square. So the square still applies. What does that square mean? It means x minus 5 multiplied by itself twice. So let's rewrite this. So we have a equals, can you see that? No. A equals pi times x minus 5 times itself twice. All right, so here we have some foiling to do. So x times x is x squared, x times negative 5 is negative 5x, negative 5 times x is negative 5x, negative 5 times negative 5 is 25, and all this is still being multiplied by pi. We'll go ahead and throw the pi at the end here. Let's simplify in the middle. X squared minus 10x plus 25 times pi. And I would argue that in this case, it would have just been better to leave it in this format right here, because right here you just have to plug in the value once, and then it'll give you the area. Now you have to plug it in 3 times. So actually, forget all this. The book says this is the right answer. Actually, it takes it a step further, but really, this should be the right answer, because you only have to plug it in one place. Yeah, I'm ashamed in the book right now. Ashamed of. All right. Number 8, we're dealing with a trapezoid. So let's get the trapezoid formula, or the formula for the area of a trapezoid, and that is going to be 1/2 height. Area of a trapezoid equals 1/2 of the height times a plus b, and that a and b. So let's take a look at a trapezoid. Trapezoid looks like this, right? So the height is just going to be this measure right here. A and B refers to the length of the longer side and the length of the shorter side. See how this side is shorter than this side down here? So it's those measures added together plus the height divided by 2. All right, so a trapezoid's longer base, so let's just go ahead and call this longer and shorter so we don't have to remember. So longer and shorter. So a trapezoid's longer base is, so the longer base is 10 feet longer, 10 feet more than the shorter, okay? And its altitude, or the height, so let's go ahead and we can call that the altitude for the sake of this problem. The altitude is 4 feet more than the shorter. All right, great. So now we can rewrite everything in terms of s. So let's go ahead and do some substitution. So let's go ahead and substitute everything. A equals 1/2. The a equals 4 plus s. And the L equals 10 plus s. And we can go ahead and simplify everything. A equals 1/2. 4 plus s times 10 plus s equals 10 plus 2s. And then if you wanted to FOIL everything out, you could do that, but yeah, let's go ahead. Because 1/2, 4 times 10 is 40, 4 times 2s is 8s, s times 10 is 10s, and then s times 2s is 2s squared, and then simplify in the middle, so we can combine the 8 and 10s to be 40 plus 18s plus 2s squared, and then distribute the half through everything, so divide everything by 2 equals 20 plus 9s plus s squared. All right. So instead of having to know the length, the altitude, and the the longer side, the altitude, and the smaller side, we just have to know the length of the smaller side, and we can figure out what the area is. And let's do number 10. Represent the difference in area for two circles with the same center when the larger circle has a radius of 10 feet longer than the smaller circle. All right, so we're dealing with two circles, so let's go ahead and just visualize them. We got one circle, and we got a bigger circle, and it says the radius of the larger circle. So this is the smaller circle, that's the radius of the smaller circle. This is the bigger circle, and this is the radius of the bigger circle. The radius of the bigger is 15 more than the radius of the smaller. Okay, so let's just so let's calculate the area of the bigger circle. So the area of the bigger circle is going to be pi r squared, and the radius of the bigger circle, which we know to be this jazz. All right, so area equals pi 15 plus r radius of the smaller circle squared. And then let's also calculate the area of the smaller circle. Area of the smaller circle is just going to be pi r of the smaller squared. All right, so it says, what is the difference between these two? So we want the area of the bigger circle minus the area of the smaller circle. We know that the area of the bigger circle is pi 15 plus radius of the smaller circle squared minus pi radius of the smaller circle squared. And if we were to work all this out, it would give us something, but I'm good with you just keeping it like this. If you do want to try to simplify it out, that's fine too. Here we have a cylinder, has a height of 10 units, and its radius is represented by x plus 3. So a cylinder is a three-dimensional object, so we're calculating the volume. Let's go to the page. The volume of the cylinder equals pi r squared, so we've seen that before, that's the radius of a circle, times the height. And if you think about it, that makes sense, because all a cylinder is taking a where's the video? Is taking a circle. Hold on. All it is taking a circle. Here, let me use my can. All right, so see, it's a circle, and a cylinder just takes that circle and goes whoop, puts it through space. So that's why it's the area of a circle times the height, because we're doing that area this many times. All right, so cylinder has a height of 10, and its radius is x plus 3. So let's substitute these into our volume equation. Pi radius equals x plus 3, and the height is 10. And if we wanted to multiply everything out, it'd be complicated. So let's just leave it. Let's just reorder it. So we put the coefficient up front, so that 10 can go 10 pi times x plus 3 squared. We really don't want to expand this when we don't have to, because it's much easier to just plug in a number there than it is to expand it out into a polynomial and then have to do it. All right, the side of the base of a square pyramid is represented by x plus 3. Another x plus 3, there you go, I like that. And has an altitude of 8, so let's go to the volume of a square pyramid. That is going to equal, volume equals 1/3 the side of the square squared times the height. And it says one of the sides is x plus 3, and the height is 8. So once again, just substitute v equals 1/3. S equals x plus 3 squared, and the height is 8. And once again, really don't want to expand it, so we'll just rearrange it to say v equals, multiply our coefficients together. There's a coefficient, so that's going to give us 8/3 times x plus 3 squared. And that's going to be the volume, and all we have to do is plug in that, whatever that's going to be, and that'll give you the volume. All right, if you have any questions, let me know, but yeah, word problems and substitution.